Hello friends, welcome back to my channel View Tutorials. In this video we will discuss about fuel and combustion. In last video we have discussed about various type of coal. Now we discuss about combustion of coal. We have seen that fuel and oxygen are essentially required for creating a fire. When fuel burns with a bright flame and heat is called the combustion. For good combustion, three entities spelled to being with a T are essential, and they are temperature, time and turbulence. In order to ignite the fuel, it is to be heated to required minimum temperature. This temperature at which the fuel can catch fire is called the ignition temperature of the fuel. There should be sufficient time for the combustible matter to react with oxygen and complete the process of chemical reaction of oxidation to take place. Finally, to enable perfect burning, the fuel is to thoroughly get mixed with combustion air, wherefrom it can get required oxygen. Unless the combustion air create a sort of turbulence, this kind of molecule to molecule mixing cannot take place. It is customary to call temperature, time and turbulence as three T's necessary for efficient combustion. A good contact between fuel particle and air is also necessary. So some people consider touch as a fourth T necessary for efficient combustion. Coal has got three distinct main constituents called volatile matter, fixed carbon and ash. The properties are mainly depend on the proportion in which these constituents are found in the fuel. Volatile matters consist of mainly hydrocarbon and a combination of carbon with hydrogen in different proportions along with other gas forming constituents. These are liberated in gaseous form when the fuel gets heated up initially and start burning above the bed of fuel with long yellow flame. Fixed carbon is a black carbonaceous product which is hard and is difficult to get ignite as compared to volatile matter. When coal is heated beyond its ignition temperature in the presence of oxygen, it will ignite and burn. Hydrogen and complex gases, commonly known as hydrocarbon or the volatile, which are present in coal, are released and these burn above fire in the form of flame. These gases contain carbon, hydrogen and sulfur, and on burning produce water in the form of vapor and carbonaceous gases such as carbon monoxide and carbon dioxide and sulfur dioxide. Since air in the atmosphere is a mixture of oxygen and nitrogen, approximately in the ratio of 1:4, under certain conditions of combustion, the atmospheric nitrogen present in the air also combine with oxygen to form various nitrogen oxide compounds such as nitrogen oxide and N2O3. The balance of unburned portion of air after combustion remain to be the inert nitrogen gas. It may so happen that the combustion air supplied for combustion is in excess and contain more of oxygen than the required for complete combustion. In such cases, oxygen gas may also be present along with nitrogen, water, carbon monoxide, carbon dioxide and sulfur dioxide in the flue gas after combustion. In case the combustion air supplied is insufficient and cannot contribute required oxygen for complete combustion of coal, there will be carbon monoxide in the flue gases. Sometimes the unburned carbon particle may still remain and soot formation will take place, which will result in smoky and black flue gases. Coal normally has some moisture in it. The moisture is known as inherent moisture. On storage also coal must be absorbed some moisture due to various reasons, and some moisture may be present on coal surface called surface moisture. These moisture will turn to steam, taking latent heat from combustion product on the burning. The hydrogen in coal also will burn to become water and evaporate to steam. Thus, the heat given for conversion water into steam is wasted heat in the process of combustion. The water vapor and sulfur dioxide gas may combine into a corrosive product called sulfuric acid, which is harmful and pollute the atmosphere. Carbon monoxide as well as nitrogen oxide are also polluting gas and are undesirable. Coal consists of 15 to 50% of ash in it, which cannot burn. The ash will get collected over the grate, which is to be removed periodically. It is also a waste product and has to be disposed of. If the temperature goes beyond certain limits, the ash may start fusing and form clinker. Coal has got its own chemical composition. It is a homogeneous composition of combustible substance such as carbon, hydrogen, sulfur, etc. The composition of coal can be analyzed and find out in a laboratory test. The heating value of coal depends on its chemical composition. Characteristic of coal or for that fact any fuel is decided by its physical properties and chemical composition only. Coal classification is also depending on its physical properties, appearance and chemical composition. Chemical analysis of coal is expressed in two different methods by which its characteristics can be understood. One is a broad classification of characteristics of its main constituents such as carbon, volatile matter, moisture and ash, and is termed as proximate analysis. Another way of understanding coal characteristics is by carrying out detailed chemical analysis of the coal in a laboratory to find out all constituents of the coal individually and is termed as ultimate analysis. Proximate analysis and important property of the solid fuel is the name given to the estimation of moisture, voltage, charge and assays, etc. In a sample of a solid fuel, the voltage and charge roughly given the distribution of the original constituents into component partaking in flaming and glowing combustion. While ash contents in wood may be negligible, coal may contain a considerable amount of ash. The sum of moisture, voltage and ash percentage when subtracted from 100 gram give the proportion of the so-called fixed carbon. The constituents given by the proximate analysis is generally used in design of boiler and coal handling plants. A typical proximate analysis given here. Solid fuels like coal, wood are graded by their detailed composition as well as the result of proximate analysis. In the case of a liquid fuel like fuel oil, additional properties, for example, viscosity, pour point, flash point, volatility, octane number become relevant. Ultimate analysis or elemental analysis is the name given to the straightforward analysis involving the estimating of important elements in the fuel. Table below gives such a data for coal, charcoal and some wood spices. A typical ultimate analysis given here for some fuels, for charcoal, soft western coal, hardwood and determination of ultimate from proximate analysis and combustion of liquid fuel will describe in detail in next video. So friends, if you like this video then like and share. Also don't forget to subscribe this channel and press bell icon for getting notification of my upcoming videos.